Ancient alien theorists manning two radar stations located B equals 43 miles apart both detect a UFO located between them. The angle of elevation by the first station A is 86.9 degrees, and the angle of elevation measured by the second station C is 84.7 degrees. Let's first label the diagram below. We're told the stations are 43 miles apart, which is the length of side B. We're told the angle of elevation from station A is 86.9 degrees, which is labeled alpha. And the angle of elevation from station C is 84.7 degrees, which is labeled gamma. For part A, how far is the UFO from station A? This would be the length of side C. And then part B, how high is the UFO from the ground, which would be the length of side H. For the first step, we'll determine the measure of angle beta, or the measure of angle B. We know the sum of the interior angles of any triangle equals 180 degrees, which means we can determine the measure of angle B by starting with 180 degrees and then subtracting the sum of the two other interior angles, meaning we subtract the sum of 86.9 degrees and 84.7 degrees, which equals 8.4 degrees. We know the measure of angle B, which is labeled beta, is 8.4 degrees. From here, because we have the measure of angle B as well as the length of the opposite side, and we have the measure of angle C, we can determine the length of side C using the law of sines. In this example, because we're looking for the length of side C, we'll go ahead and use the alternative form of the law of sines, which is the second line here. Starting with the length of side C, we have the length of side C divided by the sine of angle C, which is the sine of 84.7 degrees, equals the length of side B, which is 43 miles, divided by the sine of angle B, which is a sine of 8.4 degrees. And now to solve for C, we'll multiply both sides by the sine of 84.7 degrees. Simplifying, we have C equals, let's write the right side as 43 times the sine of 84.7 degrees divided by the sine of 8.4 degrees. And now we'll go to the calculator, and we are told to round to the hundredths place value, or 2 decimal places. With the calculator in degree mode, we enter 43 sine 84.7, close parenthesis, divided by sine 8.4, enter. To the hundredths place value, we have 293.09, which indicates the UFO is 293.09 miles from station A. For part B, how high is the UFO above the ground? And we're told to use the rounded value from part A. So let's go ahead and label side C with a length of 293.09. To find the height, we'll focus on this right triangle here in relation to angle A, which measured 86.9 degrees. Notice the height H is the opposite side, and we know the hypotenuse, which indicates we can determine H using the sine function because the yellow triangle is a right triangle. This indicates the sine of 86.9 degrees equals the ratio of the opposite side to the hypotenuse, which is H divided by 293.09. To solve for H, we multiply both sides by 293.09. Simplifying, we have the height H equals 293.09 times the sine of 86.9 degrees. And now we go back to the calculator, and again we're going to round to 2 decimal places, or the hundredths place value. H is approximately 292.66, which indicates the UFO is 292.66 miles above the ground. I hope you found this helpful.